Hello everyone, I am Surendra Sir, Master Teacher of Mathematics in Vedantu. I am teaching maths for last 14 years for 𝐢𝐭𝐞𝐫, RMO, INMO, JEE Mains Advanced, ISI, CMI. So I have got opportunity to teach all kind of students, to interact with all kind of students so far in this 14 years. In these sessions, as I was talking about in the last session also, I am trying to give you certain insights on some selected subtopics where I give you shortcut alternate ideas to solve questions, which will help you save time in solving those questions, to get new ideas so that it will become possible to solve those questions during exam pressure. Okay, before I start my session, one thing you might have heard about Daksh, who got All India rank 15 in 2025. He was student of Arambh 20 to 25, where I was teaching him for 3 years. He got 120 marks out of 120 in maths in JEE Advanced 2025. Through these sessions, we are trying to repeat that performance, repeat that result. I'm sure many of you will come forward and will give that kind of performance in the next JEE Advanced. Okay, so in this session I will be talking about alternate approach to find nth term and sum of n terms of AP, GP, AGP, and also those series whose first second order differences are in AP or GP. Okay, so I will start with AP and then first and second order difference in AP. I will be telling you something which will be the starting of something that will come in second order, third order difference. So just be patient, because this can be very easy for you. Okay, so here let's say we are given AP whose terms are A1, A2, A3 and so on. Now as we know, for AP, difference of two consecutive terms is constant, that is D, and I will be writing the difference of two consecutive terms in between, like A2 minus A1 is D, similarly A3 minus A2 is also D, okay, and so on. If you further write this difference, I think it will be 0, 0 and so on. So there is no need to write further, write only till those steps where you get non-zero values. Okay, now if you want to know the nth term and sum of n terms, my first method is, I will be talking actually about two methods. My first method is that Tn of this series would be, you just circle the first two terms, first terms of these two series, first the given one and second by taking the difference. Then this Tn would be A1 multiplied with n minus 1 C0 plus D multiplied with n minus 1 C0. You can verify by putting the values of n minus 1 C0, which is 1, and n minus 1 C1, sorry, this was n minus 1 C1, so that will be n minus 1 into D. So you can see this Tn can be found that way. Now why this way? Because this will be repeated, this will be used same way in other series also. Now sum of n terms if we are looking for, then same way we will be writing A1, but this time it will be nc1 plus D into nc2. You can check, if you open this value, this becomes A1 into n plus D into n minus 1 upon 2, and you can check it becomes n by 2 into 2a plus n minus 1 into D. Okay, so this is how you can find nth term, sum of n term. This same thing will be repeated when you do it for first order term difference is AP, second order difference is in AP. Okay, but before that I would like to tell you one more method. Okay, this is called coefficient method. Many of you might be knowing, but I will add something here. Okay, and by doing that you will need two less terms to find in AN and one less term in SN. Let me first tell you what I am talking about when I am saying two less term or one less term. So suppose your AP is A1, A2, A3 and so on. Okay, now here let's try to follow this pattern backwards and write one term that is before A0, and we may call this as A0. We may call this as A0. A0 is not the part of, I think I should use different color. Yeah, this is not visible. Yeah, so A0. Okay, this is not part of this series. I am just writing so that I can use it later on. Now this A0 would be, you can see, A1 minus D. A1 minus D, it will just be A1 minus D. Now what I am going to say in this method, if we have to find Tn, okay, I think we know it that nth term of AP is always, you know, linear in n, and linear in n, the coefficient of n is the common difference D, and there will be another term, constant term, and that will be A0, that will always be A0. So just by, you know, going backward, writing A0, you will be able to write Tn directly. Okay, now if we want to know the Sn, please listen carefully. In this we know it's a quadratic whose constant term is 0. I think for AP everybody knows, but for first order, second order, then I will tell you how this can be, that can be used there also. So Sn, to write Sn from Tn, what we have to do? We have to listen carefully. I am using the term, do the integration. What I said? Integration of the leading term only. Integration of leading term. So this will be the leading term for Sn, and then some other term, let's say An. Okay, constant term will not come. The characteristic of any Sn for sequence should be that S0 has to be equal to 0. When we are saying sum of 0 terms, that means you are not adding anything, so sum has to be 0. So if you are writing any constant term that is not 0, then this S0 cannot be 0, so hence it has to be 0 here. Now to find this A, because already the coefficient of n square is found in terms of D. Now if we are looking for A, you can do two things. One is S1, because we know S1 is A1, and that is equal to D by 2 plus A. So from there we get A equal to A1 minus D by 2. Okay, so this is how we find A. There can be another method, but I will talk about that in the series when first order difference will be AP or second order difference will be AP. Here I think that is sufficient. No need to, you know, extend it further, because this method is that much only. So two ways. One is the method of n minus 1 C0, nC0, etc., and other is this thing where Tn is this and Sn is found by integration, but integration only for leading term. Do not try to integrate A0. No, it will not work. Only leading term will work. Okay, so this is how you can find nth term and sum of n terms for AP. Now I will come to series. Okay, but before that, one example is there, very simple example. I think you can write Tn as 4n, and my 0th term, what should have been the 0th term here? I think 4 I have to subtract, so 0th term will be minus 1. So this series will have nth term would be 4n minus 1. Now you can check every value should satisfy it. Now coming to Sn, as I told you, the leading term should be integrated, so it will become 2n square plus some an. Now to find A, you need to put S1. S1 has to be always first term, that is 3. So that will be 2 plus A. So we got A to be equal to 1. So my Sn is equal to 2n square plus n. Now you can check that for every n this should work, like n is equal to 2. If you put 2 into 2, 4 into 2, 8 plus 2, 10. The sum of first two term is 10. So this is how it is working. Now the other method, in fact the first method that I told you. Now if you want to know Sn directly, let's not talk about Tn, we have already found it. So Sn, if you have to find directly, so what we will be doing, we will be taking these first terms of the two things, the given series and the series, by taking the differences. So it will be nc1 into 3 plus nc2 into 4. That should give you the same result, 3n plus 4 into n minus 1 by 2. So this will be equal to, I think, 2 n square minus 2n plus 3n, and you can check we are getting same answer. Now whatever you are comfortable at, you can use it. Okay, so that is for AP. In fact, you may say that why we are doing it for AP, we know it already. Okay, that's fine. But now these methods which I have discussed with you, I will use this in those series where the first difference is in AP. First difference is in AP. So let's see how it is done. Suppose my series is given, series is A1, A2, A3, A4 and so on. Now I am talking about that series whose first difference is AP. So if you take the difference and let's say we get B1 here, we get B2 here, we get B3 here and so on. Okay, if you once again differentiate it, I think you will be getting D here, you will be getting D here. That is the common difference of the series B1, B2, B3 and so on. Okay, now the same method बच्चों, Tn, if we want to know Tn, it will be n minus 1 C0 A1 plus n minus 1 C1 into B1 plus n minus 1 C2 into D. I hope you understand what I have done. I have taken the first terms of these three series which I have obtained by taking differences. So n minus 1 C0, n minus 1 C1, n minus 1 C2 into D, and this is how we got the we got the nth term. Now if you are looking for sum of n terms, then it is just write nc1 A1 plus nc2 into B1 plus nc3 into D, and that's it. Okay, so if you are having this series, just take the difference, the very first terms, with the help of them you will be able to write Tn Sn directly. Okay, it looks that it's very easy, and it is actually very easy, but if you want to know the expression of Sn in terms of n directly, then you may have to open nc3, nc2, but yes, it is still useful in many other cases. Okay, now what can be the other method? So my method 2, let's see what is method 2. In method 2, I will be taking A1, A2, A3. Okay, now B1, B2, B3 are their differences, and D is further differences. Now, as we know, B1 is AP. So B1 has to be, as I told you in the previous slide also, it has to be n into D plus B0. Okay, and what is this B0? I told you B0 would be something if we follow this pattern of AP backwards, one step backwards. So B0. So B1 will be equal to n into D plus B0. Now by taking the differences, I think we can follow the pattern of A1, A2, A3 also backwards by 1 unit. In fact, what will happen here, your A1 minus A0 will be equal to B0. If we know B0, I think B0 has to be equal to, actually B1 minus B0 has to be equal to D, because here all the differences are D. So B0 you can find A0 also. So these two things you have to follow this pattern backwards and write A0 B0. Why I am writing again and again B0 A0, that you are able to write B1 directly. Now if you have to find AN, you have to find the AN. Okay, that is nth term of this sequence. You may write this as AN. Okay, so this will be, please listen carefully. Here once again, just like I did for summation in the previous slide, here also we have to do the integration of leading term only. Leading term only we have to integrate. Okay, nothing else. And then there will be term with coefficient, term of n whose coefficient will be, let's say, small p into n. Okay, and then there will be a constant term, and that constant term will be A0 always. That constant term will be A0. Okay, now you may be knowing it that when first order difference is AP, then nth term is quadratic. Now can you see it that I have told you the nth term will be having the coefficient of n square as d by 2, and this we have done just by integration, and A0 we have done by following the pattern backward. Okay, so you can now see in this AN only one coefficient is to be found, that is P. And to find P, I think to find P, we can use n is equal to 1, and we will be given this A1 in the question. So that will be equal to D by 2 plus P plus A0. And from that we can find P. Okay. I'm not asking you to write this as a formula, you just understand the process. Okay, so we got P here. Now if we have to find the summation of this an, if we have to find the sum of n terms of this an, now once again, as I told you for leading term, what we did integration. Here also we will be doing integration, but again for leading term only. Do not ever try to do integration for other terms. So here it would be n cube upon 6 into d plus, and let's say capital P n square plus capital Qn. Okay, so these two unknown coefficient we have to find. Already I told you, for any Sn, sum of zero terms should be 0, so there will be no constant term here, so it will go only up to Qn. Now we need to find P and Q, and we are done. We have to find one less coefficient, because this we have found by following that integration thing of leading coefficient. So P and Q we have to find. Now how to find P and Q? Now dear all, listen carefully. I got Sn to be equal to, I think, n cube upon 6 into d plus Pn square plus Qn. Let me just verify. Yeah, this was n cube by 6 into d. Yeah, that's correct. Now to find P and Q, what I will do, I will write S1 as A1 only, so that will be one equation. So we get n cube, not n cube, we get d upon 6, because n is equal to 1, plus P plus Q. Okay, now most of you put n is equal to 2 to get another equation. That can definitely be done, but I am going to tell you one more thing, and that will be useful for other things also. So please listen carefully and remember it, that whenever you write this A1, A2 and A0 and all, this S minus 1, you may say that sequence and series start with first term, second term, but I am not saying sum of minus 1th term. I am saying whatever expression of Sn we are getting, if we consider this as that as a function, and I put n is equal to minus 1, it always comes out to be minus A0. It comes out to be minus A0 always. Okay, not only in AP or difference is AP or difference of difference is AP, in GP, AGP, any series if you take, always S minus 1 will be equal to minus A0. You may find out why. I will put this thing in my session notes. Okay, you can find why S minus 1 is minus A0. Please see there. Okay, now why I am doing this thing, bacho? Because if you take S minus 1, okay, and as I told you it is minus A0, and I told you how A0 is found by following this pattern backward. Okay, so this minus A0 will be equal to, put n is equal to minus 1, so we get minus d by 6 plus P minus Q. Now I think coefficients in this equations are better than if you would have put n is equal to 2. So if you add, you get P, you subtract, you get Q, and done. Okay, so this is how you deal your series when first order difference is in AP. Now I'll take one example here. Okay, now there are two methods. My first method, as I told you, you can write an directly, which will be n minus 1 C0 into 4 plus n minus 1 C1 into 3 plus n minus 1 C2 into 4. These three terms we have to use, and we get the nth term directly. If you have to find the sum of n terms, that can also be done. Just nc1 into 4 plus nc2 into 3 plus nc3 into 4. Okay, that's it. We get the sum of n terms, nth term. So what I started with AP, we are using it for those series whose first difference is AP. You can see this was the series first difference, and then later on 4, 4, 4, 4. Now in my method, if I have to find Bn, it will be, because the common difference of this is 4, so it will be 4n. And if I write B0, the term coming before this, I think if you subtract 4 to it, I think it will be minus 1. You can check. If you follow your pattern backwards, it was 3 plus 4, 3 plus 4, 7, 7 plus 4, 11. So here it should have been minus 1. Similarly, here it should have been 5, isn't it? because whatever is written here, it is actually difference of these two. 7 minus 4, 3. So here, if it is minus 1, it should be 4 minus 5. So here A naught will be equal to 5. So with this, I think now we can do the calculation very easily. So what we got, Bn will be equal to 4n minus 1. Okay, now if we are looking for an, as I told you, it will be coming by integration of leading term to leading term. So for leading term, it will be 2n square. Okay, then p into n for the term with n, and then constant term, that constant term will come from there, that is p. The constant term will come from a naught always, so that putting n is equal to 0, matches with this thing. So we are getting an. Now to find an, one thing is remaining, p. I think just one thing, p, n is equal to 1 if I put, we get 4, and this is equal to 2 plus 5, 7 plus p. So from this we are getting p is equal to minus 3. So your an is equal to 2n square minus 3n plus 5. Many of you would be able to do this calculation in the mind itself. There is no need to write anything, because 2 will come here, 5 will come here, and I need 4 when n is equal to 1. So 2 plus 5, so p has to be minus 3. That way also you can do this an for those series whose first order difference is ap. Okay, now you can check for n is equal to 2, it should give you 7, 2 into 2, 4 into 2, 8 plus 5, 13, 13 minus 6 is 7, that's correct. N is equal to 3 if you put, it should give you 14 and so on. Okay, so this is method to find an. Now if we are looking for Sn, sum of n terms of this series, again the leading term to leading term, it will come by integration. So 2n cube by 3, integration of 2n square, and then it will be capital Pn square plus capital Qn. Only two unknowns are there. Okay, otherwise those who do it by coefficient method, they take one coefficient here, one here, one here, so total 3 coefficients. To find these 3 coefficients, you put n is equal to 1, 2, 3, solve them. I think it's a big task. Here I have saved at least one coefficient to be found. Only 2 are unknown. For this you need one less equation, and that too will be easier if you follow me what I am saying. Now S1, as I told you, will be just S1 will be equal to how much? I think 4, because it is just the first term. So 4, and that will be equal to 2 by 3 plus P plus Q. Okay, now S minus 1, as I told you, it will be always minus A naught. So it will be minus 5. S minus 1 will be minus A naught. So it will be equal to how much? Minus 2 by 3 plus P minus Q. Now these two equations you just have to solve, and you will be able to get P and Q, and we are done. Okay, now the same system, same process we have to follow for that series also, when difference 2 times difference is AP. Okay, so what will happen this time? A1, A2, A3, A4 and so on. This is AP. The difference of this is this is not AP, this is some sequence AN, let's say. Then B1, B2, B3 are the first differences, and then if you once again take the difference, C1, C2, C3 is the second differences, and this is AP. So after that you will be getting D, D, D and so on. This is Bn, this is Cn, and this is constant series, you can say. Now I have already told you how to find Tn by that method of NC, so that will be n minus 1 C0 into A1 plus n minus 1 C1 into B1 plus n minus 1 C2 into C1 plus n minus 1 C3 into D. Okay, what we have done, we have taken these initial terms of these 3 sequences. Okay, same way you can do it for Sn also. Let me not write it completely, I'll just write the first term, NC1 into A1 and so on. What will be here? I think NC4 into D. NC1, NC2, NC3, NC4. All the terms will be multiplied like this. I have written these things in my session notes also, you can go through that also. So that is one method. Okay, now coming to the second method. Now in this case, Cn has to be n into D plus C naught. I hope you know by now what is my C naught. you follow your sequences one step backward. So B0 and A0. I am sure you can now find how C0 is found, how B0 is found, how A0 is found. Okay, I will tell you this thing with one example also. Okay, so now Cn is Nd plus C0. Okay, and if we have to find Bn, this series. Okay, I think because our ultimate purpose is not to find Bn, it is to find An. So I am just writing the first leading term that will come by doing the integration and maybe some other things. If you want, you can find that also, but that is not needed. Now we are looking for An. Now in this case, once again, integration of leading term is needed. So it will become n cube upon 6 into d. Okay, then p into n square plus q into n, and then constant term that will be always A0. So you can see here also where you would have needed 4 coefficients, you now need only 2 coefficients. This term is coming from the integration, constant term coming by just observation. So p and q you have to find, and you can do it by putting A1 and A2. A1 and A2, if you use, you will be able to find P and Q. Okay, I am not doing it. Now similar to this, if you want to find sum of n terms of this series, leading term will again be integrated. It will be n power 4 upon 24 into d plus n power 3 into capital P, n power 2 into capital Q plus n into R. Okay, now here there are 3 coefficients and there is no shortcut. We have to find these 3 coefficients. Now to find these 3 coefficients, you may choose to use S1, S minus 1 and S2. Now these 3 things will give you 3 equations. You can find P, Q, R. Okay, this is still better than if you are finding 4 coefficients, because this coefficient is anyways you know it, d upon 24 for n power 4. Okay, so in my method here you are finding 1 less coefficient. In case of An, you are finding 2 less coefficient. For Sn, after writing for Sn, I am asking to use S minus 1. I am using to use S minus 1, which will always be equal to minus A0, and that will help you to get better equation to solve, because coefficients would be just plus 1 minus 1 plus 1 like that. So for these 2 it will be better, and then S2 just it will be 16 upon 24, but you have to make one equation by putting n is equal to value other than 1 and minus 1, so you can't help it. So these 3 equations will give you P, Q and R. Okay, you otherwise doing these questions by doing sigma notation, that also you can do, but this is alternate method and this is better, let me tell you Vacho. Okay, now this is one example. I think that first method n minus 1 C0, I am not doing it. It is given in your session notes, and now it is very trivial. You know how it is done. Now if you have to find the An and Sn, let's do it completely. Okay, so first of all, let's write this color will be better. Let's write one term before it. So for this 3 3 3, it will be 3 only, the term before the sequence. Here because 3 the difference 6 minus 3 was 3 here, I think here it should be 0. Is that correct? Because 3 minus 0 is 3. This is how we are finding one term before the first term. Okay, following the pattern. Now here if it is 6, this should also be 6. 6 minus 6, 0. Here it should be, if we want this to be 6, I think it should be minus 3. So 3 minus 3 is 6. So you can see A0 is found, and it is equal to A0 is found, and that is equal to minus 3. Okay, now we will write An directly. Let's find An directly. Now to find An directly, we need to understand in the Cn leading term would have been 3n. In this case leading term would have been 3, here leading term would have been 3n. In this case it would have been 3n square by 2, leading term I am talking about. In this case it will be integration of this, so it will be n cube upon 2. By 3 will get cancelled, and that's it. Plus now we need to know P into n square plus q into n plus constant term, that will be minus 3. That will be minus 3. Why? Because a0 is minus 3. Now to find my pq values, I will use a1, okay, which is 3, okay, and a2, which is 9. Now two equation has to be used to get p and q. I think this can be done. I will not do it completely. You can find p and q. The solution is given in the session notes. You can check there also. Okay. Now to find Sn, what we need to do, if we want to find Sn, once again one integration is to be done. So n power 4 upon 8 plus p into n cube plus q into n square plus r into n. So 3 coefficient need to be found for Sn. Now to find first equation, I will write S1. S1 will be just 3 first term, and that is equal to 1 by 8 plus p plus q plus r. Then S minus 1. S minus 1, as I have told you, it is always minus a0. So minus a0 means it will be 3. So it will be plus 1 upon 8 minus p plus q minus r. Okay, using these two, if you just add them, I think q value is found, isn't it? Q value is directly found. So it will be 6 this side. I think if you add them, you get 6 equal to 1 by 4 plus q. So I think q will be 3 minus 1 by 8. 23 by 8. The value of q is coming out to 23 by 8. Already one coefficient is found. Now to find 2 more coefficient, I think I have to use S2. S2 would be 3 plus 9, 12. Sum of first 2 terms, 12. So that will be equal to, if you put 2 is n is equal to 2 here, so that will be 16 by 8. So 2 plus 8p plus 4q plus 2r. Okay, already the value of q is found. So now to find p and r, you can use maybe this equation with this, or any 2 equation you can use, and you will be able to find p and r. I'll write the values which I am getting. Q was 23 by 4, 23 by 8. P, you can check, will come out to be minus 1 by 4, and r will be 1 by 4. Okay, so that's how it is done. Okay, so series, when it is AP, or first order difference is AP, or second order difference is AP. In fact, if third order difference is AP, then also you can extend it. But once again, whenever one order is increased, your number of coefficient will increase by 1. Okay, but these both method will definitely work. So this is one previous year question of 2022, where we are given L1, L2, L100 consecutive terms of AP with common difference D1, and W1, W2, W100 consecutive term of another AP with common difference D2. Okay, D1, D2 product is 10, and for each 1, 2, 3, 100, Ri is rectangle with length Li coming from first AP, Wi coming from second AP, and area Ai. Okay, so this area Ai is actually coming as Li into Wi, where Li and Wi both are, APs. So the general term of Li will be linear in N, Wi will also be linear in N, which means the AI series will be having quadratic in N. If it is quadratic in N, this means it should be some series whose first order difference will be AP. First order difference will be AP, like A51 minus A50, they have given 1000, then they are asking A100 minus A90. So what I am saying, let me write it here. Suppose A1, A2, A3 and so on, if I write, okay, A50, A51 and so on, 51 and so on. Now as I told you, AI is having quadratic in N because Li will be linear in N, Wi will be linear in N. If you multiply them, you will be having AI to be a series whose nth term is quadratic in N, which means if you take the difference of these two, let's say it is A1 here, A2 here, A3 here and so on, and 50 here, and so on. Okay, that has to be AP. That has to be AP. Now let's find out AN leading term, because LI its common difference is D1, so the general term of LI would be DN plus L naught. I hope you remember L naught term. Similarly, this was D1, then D2N plus W naught, the zeroth term of this series. Okay, so you can see in this AN, the leading term is coming out to be N square into D1 D2, where D1 D2 is 10. So leading term is coming out to be 10N, and rest I am not bothered about. AN is 10N square. Now please listen carefully. If AN is 10N square, now please remember, I told you whenever this nth term is found, we do the integration of leading term. We do the integration of leading term to get the leading term of AN. Now we want it to do otherwise. We want we want the difference of two terms. I am actually looking for this series where A1, A0, A3, A50 are there. I'll explain you why I am looking for this, but let's first understand that if we know A1, A2, A3, the difference of two consecutive terms would be AP, and if we can find this AP, I will tell you how this will be found. Okay, but for that, let me know, if I need to find this AN, can I say directly that it will come by the differentiation of the leading term? Why differentiation? Because we are going downwards. Earlier we were coming upwards. So AN will be 20N plus maybe some constant. Okay, because this integration thing or in differentiation thing will work only in the leading terms. Okay, but here you can see A50 is what? A51 minus A50 is given us to as 1000. So if there was some constant C, I think this constant is coming out to be 0, because for A50 they are giving us the value to be 1000, and that is 1000 plus C. So C is coming out to be 0. So my AN is actually 20N now. Okay. Now they are asking this thing. Now can I say that A100 minus A90 is actually, let me go to the next slide. No, I am not having the page. Yep. Okay. So A100 minus A90 is what we are looking for. A100 minus A90 is what we are looking for. I can write it as A100 minus A99 plus A99 minus A98, okay, and so on, A91 minus A90. Now if you compare it with this series, small a1, a2, a3 and so on, can you see it that it is actually, I think this is A99, this is A98 and so on, and this is A90. Okay, and we know for AN, we solved in the previous slide, AN was coming out to be, I think, 20N. So I think all the values we know. This will be 20 into 99. Okay, this will be 20 into 98 and so on. This will be 20 into 90. I have taken 20 common, so you can now find the answer. Okay, you could have done it otherwise also. I am not denying that thing. Okay, by actually multiplying this thing completely and then using this A51 minus A50, that way you can definitely do it. But as I have told you that how the nth term becomes when your consecutive when difference is in AP or second order difference in AP, I have used that thing to get this answer. Okay. There is one more question which I am having. This is from PYQ 2022. Here they are saying A1, A2, A3 is AP, with A1 is 7 and common difference is 8. Okay, and let T1, T2, T3 is such that T1 is 3 and Tn plus 1 minus Tn is A. And I think it is exactly similar type question which we were talking about. So let me write it here. A1, A2, A3 and so on, that is AP. Now T1, T2, T3, T4, I can write it here so that T2 minus T1 is A1, T3 minus T2 is A2 and so on. So this is what they have given. Now this is AP with common difference is equal to 8. Okay, so if you take one more difference, it will be 8, 8, 8 and so on. Okay, now they have also given you T1 is equal to 3. They have given you T1 is equal to 3 and A1 is also known to us as 7. I think you understand now what is to be done. To find Tn, you can use that n-1c0, n-1c1 method, and that way you can find T20 or T30, whatever you are looking for, isn't it? If I am looking for Tn, it will be n-1c0 into 3 plus n-1c1 into 7 plus n-1c2 into 8, and that's it. This kind of question I have already done by the second method, so I will skip it. I have given that solution also in my session notes, or you can do it now because it's not difficult at all to find Tn by that coefficient method. Okay, you just have to write T0. Please take care of the T0. You will get T that thing directly. And similarly, if you are looking for Sn, it will be Nc1 into 3 plus Nc2 into 7 plus Nc3 into 8. Okay, so this way you get expressions for Sn, Tn directly and then put values of n as 20, 30, get the answer. Okay, by coefficient method also you can do it. There is no doubt about that. Okay, here it is 8, so your An will be 8n plus something. So Tn, if we are looking for, do the integration, 4n square plus something here and then T0. Now to recognize what is T0, I told you this will be 8 here. So A0 term before that has to be -1, so that difference is 8. Now if this is 3, okay, and if this is 3, A1 was this, 1 minute, what should be T0? T0 here, so that I get -1 here. I think it is 4. Yeah, I think it's 4. Okay, so that 3 minus 4 is -1. Okay, so here the constant term would be 4. Constant term would be 4, and by looking at T1, that is 3, I think I can write directly. It will be 4n square minus 5n plus 4, and that's it. Okay, so this is how you get Tn directly. I think I have explained it in detail before also, but now you see how these things becomes easy if you keep these things in mind. Okay, and this is not difficult. We already know that AP has property that nth term is linear, Sn is quadratic. You just have to remember it whenever you go one step ahead, means the difference is AP. Then you have to do the integration of leading term, only leading term, nothing else. And if difference 2 times difference is AP, then 2 times you have to do the same thing. So this is how these kind of questions are done. Okay, now coming to GP. Okay, now before I start for GP, I would like to tell you that if you are comfortable with your GP method, okay, if you are comfortable with your GP method, I think that is okay, because the method which I am going to tell you, I also not feel that it is so great, but yes, it's an alternate method. So you can listen what I am going to tell you. If you want, you can apply this also in your questions. So in GP, as we know, it will be A1, A2, A3 and so on. Okay, this time difference will not be constant, so there is no point writing like that. Here the nth term, is written like A1 into r power n minus 1. This we know. Okay, here I will suggest that you write it as An is equal to A0 into r power n. This A0 is the same thing which I was talking about there. Okay, how A0 you will find? Just follow the series one step backward. So it will be An equal to A0 into r power n. Okay, it's the same thing. Actually A0 will be A1 upon r. So it's same thing. Okay, now if we have to find the sum of n terms, we know the formula already. Okay, and you should know it. You cannot make excuses for not knowing this formula of Sn, but if we have to find Sn here, okay, this alternate method I'm just telling you, it will be a into r power n plus some constant b. That's it. There will be just two terms. For r power n, it will be r power n only. Okay, just term, some coefficient will change. Okay, it is not that kind of thing where n square become n cube. In fact, if you like to connect it through integration, you can still do it. Okay, r power n is like a power x. Why? Because r is fixed, n is variable. Now a power x, if you integrate, I think its integration remains ax only. You have to divide by, I think, log a, but that's a constant term. So if you are doing the integration, because summation is somewhere related to integration, so this leading term or coefficient actually of r power n will change, and it will be some a and some other constant will be b. And as I told you there also, that whenever s naught is to be found, it has to be 0. This gives you that b will be equal to minus a. This gives you b will be equal to minus a. Okay, and then s1 will give you all the values. How? S1 will be a1, and that will be equal to a r minus a, because b was minus a. So from this we are getting a equal to a1 upon r minus 1. So now you can see we get Sn. We get Sn, that is equal to a1 upon r minus 1 into r power n minus 1. I think that is the sum of n terms of GP. So this way you can find out, but you have to understand for a naught into Rn, the summation will be having same Rn but different coefficient, but some other constant also. In fact, when you do the integration, okay, then also same thing is happening. So from there also you can connect with, but your coefficient will change and some constant term will also come. Constant term should come so that your S naught become equal to 0. Okay. So that is when you're having GP. Now if your first order term, first order difference is GP. So let's say my series is A1, A2, A3, A4 and so on. The difference is B1, B2, B3 and so on. Okay. Now this is GP, this Bn is GP. So in this case Bn would be equal to B naught into R power n, where R is the corresponding common ratio. Okay, B naught, you know how to find, how we find B naught, but just by looking at the pattern backwards. Here also you can find A naught. Okay, so Bn is this thing. Now to find An from Bn, what we have to do, once again same thing, A into R power n plus B, same thing that we did for summation. But here A naught will not be 0, because A naught will be some value, it will not be 0. So A and B will not come directly. You have to put n is equal to 0 and n is equal to 1 to get the values A and B. Okay, so two equations, n is equal to 0 and n is equal to 1, will give you these A and B for this kind of series directly. Okay, you can do the difference method also, but this is the method of coefficient when first difference is GP. Now when you are looking for summation of this thing, when you are looking for summation, that is Sn, in this case A into Rn, this A into Rn will go to some different coefficient A into R power n. Once again you can connect this with integration thing, so it will be some different coefficient but still constant. Okay, then for B, let me tell you, the same B, whatever B you have obtained here will be just written as B into n. There is no need to find this separately, this is already known. And then plus Q, another constant, so that S naught can be made 0. So in this method you need to find only two coefficient, one is P, one is Q, that's it. Okay, B is already found in An, the same B will be copied here when your first difference is in GP. Okay, I will show you this through this example. Okay, so first I like to write that zeroth term. So 3, 9, 27, I think zeroth term should be 1 here. Is it visible? Yeah, it is clearly visible. So B0 will be 1. Now if I have to write A0, what should it be? I think 5 minus 2 was 3, and if I want 1 here, it should also be 1. So you can see difference is they are matching. So my A naught is 1, B naught is also 1. Now we are looking for AN. Already Bn would have been 1 into R is what? 3, so 3 power n. I think that's quite obvious. So AN would be some constant A into 3 power n plus some constant B. Okay, now to find A and B, I will put n is equal to 0. So my zeroth term is 1, that is equal to A plus B. Okay, and if I put n is equal to 1, I should get 2, that will be 3A plus B. Solve these, you take the difference. I think A will be half and B will also be half. Yeah, okay, now you can check whether our value of AN is coming out to be correct or not, as I am claiming it to be 3 power n by 2 plus 1 by 2. Okay, so this is first term, this is second term. So if you put 2, so 3 into 3, 9 plus 1, 10 by 2, 5, correct. If you put 3, so 3 power 3 is 27 plus 1, 28 by 2, 14 is correct. If you put 4, so 81 plus 1, 82 by 2, 41 is correct. I think everything is matching. Okay, so this is AN. Now if we have to find the SN for this series, so what I told you, for this 3 power n, there will be some separate coefficient Pn. There will be some separate coefficient P, but it will be multiplied with 3n. This 1 by 2 will be now n into 1 by 2. Let me write that way, n into 1 by 2. Okay, and then there will be one more constant, so that S naught will be 0. Okay, so S naught has to be 0, and for that it will be P plus Q. So Q will be minus P only. That's one equation. Now to find P or Q, I think I need one more equation, and now it's up to you. If you want S1, yeah, I think that's fine. It will be 2, and that will be, if you put n is equal to 1, so 3P, okay, plus 1 by 2, I am putting n is equal to 1 plus Q. Okay, P plus Q is 0, so this will remain 2P. So P will be equal to, I think 1 minus 1 by 4, so I think 3 by 4. P is 3 by 4 and Q is minus 3 by 4. So sum of n term should have been 3 by 4. P was 3 by 4, yeah, 3 by 4 into 3 power n plus n by 2 minus 3 by 4. Let's see that's correct or not. We can check it by putting n is equal to 1, 2, 3 and so on also. Yeah, 3 by 4 minus 3 by 4 and 1 by 2. If you put n is equal to 2, if you put n equal to 2, okay, my sum should have been 7. For n is equal to 2, sum should have been 7. If you put n is equal to 2 here, so 9 into 3, 27 by 4. If you put n is equal to 2, that will be 1 minus 3 by 4. So 27 minus 3 is 24, 24 by 4 is 6, 6 plus 1, 7. So for n is equal to 2, we are getting correct. In fact, it has to be correct for all values of n. So this is how you can find sum of n terms of those sequences whose first order difference is GP. Okay. Now if we have to find second order differences in GP, I think same thing will be continued. Same thing will be continued. Here, suppose A1, A2, A3. Okay. First order differences, let's say B1, B2, B3. And then third order difference is C1, C2, C3. Okay, and this is GP. This is GP actually. Okay, so if I write all the C naught terms, I think you are now familiar with what I meant to say when I am saying C naught, A naught, B naught. Okay, so Cn will be C naught into Rn. Okay, Bn will be equal to some other constant A into R power n plus some constant B. For Cn, for An it will be some other constant, let's say P into R power n, okay, plus I think it should have been Bn only, plus C. Let me just think. Yeah, I think it will be same B only here. Okay, same B here only. In fact, you will not be finding Bn, you will be finding directly An. Okay, so we started with here. In fact, we can come directly here also. There is no need to write Cn, we can directly write An. Okay, similarly, now if you have to find the sum of n terms, would be, there will be some other coefficient. Let me call that coefficient should be, what can I take, q, let's say. So q into r power n. Okay, now for Bn, only for this n, okay, it has to be Bn square by 2, direct integration this, but the C will not be same. The n term will also come, but that will not be this C into n, it will be some D into n and some E here, so that we can make S0 to be equal to 0. So let me repeat what I said. When you are going from An to Sn, P will change, B will not change, this constant term C will not be the coefficient of n, it will change. Okay, constant term will be some value, so that S0 is equal to 0. So here you have to find three things: Q, D and E. Q, D and E. I hope that is clear to all of you. I think I am not having example on this, or let me see if I am having. No, I'm not having the example on this. Okay, we may create it, or I will do one thing, I will put one example on this also in my session notes, so please go through it. Okay, now coming to AGP. Okay, now AGP, once again I will suggest you go by your conventional method, but I will still just tell you how AGP can be dealt with. You know, in AGP the nth term is a plus n minus 1 into d multiplied with r power n. Okay, now you can write this as with some other coefficients, p into r power n plus q into n into r power n. So there will be two terms, p into r power n and q into n into r power n. Okay, now if you want to know the sum of this thing, okay, so you will be getting some other coefficient p into r power n for this. This will again be same thing, q into n into r power n. This q will change, that will be some other coefficient. Okay, so one term will be from this, one term form will be this, and then you will have some constant term, let's say r, so that the sum, entire sum will become equal to 0 for n is equal to 0 actually. Okay, so what I started with AP, difference of difference AP, then GP, difference of terms GP, then difference of difference GP, then AGP. Now for AGP, if you are okay, you can do it, but I will still say this is not very much asked, so you go with your conventional method for AGP, but yeah, still this method is there.